So today's going to look a little bit different. We're going to do one of these together. I'll tell you this up front. They are fairly challenging, especially in the beginning. We're going to do one together. I'm going to give you some strategies. And the strategies must be used. Okay? We'll talk about that when we get into them more, I guess. And then you're going to try a bunch on your own. And I would encourage you to try with a partner or with a couple of people. We'll talk about that a bit more at the end as well. But it's better if you're working with somebody on these. Okay? So, and that's kind of how the period's going to go. And then there are more for practice and that are posted to Google Classroom that you can try yourself independently later. But I'm going to give you another handout that's got, I think, 5 on it. And you can try those with a partner. If you're working on your own, I'll come around and help you as well. And you can talk to me about it and make sure that everybody's on track and understanding. They are tricky. They're tricky because these are very different word problems. This is called mathematical models, but really what this is word problems, applications. Okay, but you've never seen ones quite like this before. Some of them are kind of similar to grade 10 questions, but we're going to solve them in a very different way. And so they're very different. And so when you read it, you're like, I don't even know where to start. But this is what I'm telling you is these tips, or really it's just how you're going to solve them. That's what you do. You have to do these 4 things. You have to force yourself to do them. And then you'll be able to get through it. Okay? The first one's probably the hardest in some ways just because it's the first time you're doing it. And then you start to get the hang of it. And hopefully by the end of the sort of period, and that's what happened with the previous class, by the end of the period, they were getting it. Okay? Okay. So here are the tips, or really steps to solving. The first thing you're going to do is do a couple of let statements. And I think pretty much all of these are going to have 2. Okay? And this is a tip that works in almost all word problems in all of high school, except for kind of 1 in grade 10, 1 or 2 throughout all of high school. You're letting X represent the thing you're trying to find. So if it says, find Billy's height, let X represent Billy's height. Do you understand what I'm saying? That's how the let statement works. There are a couple of exceptions, but for these ones, that will work. Okay. Then you're going to come up with some expressions. We're in the rational functions unit. Some of these you could solve the grade 10 way with a linear system. That is not how we're solving these. We're not learning about linear systems right now. So you have to model these as rational equations. Okay. That's the whole point of this. So you've got to write out some rational expressions. So that's going to be your next part. And when you do that, and I'm going to explain what this means when we do the example, because I know this might seem a little cryptic right now, but when you do that, you have to think, what does the expression that I just wrote, what does it mean? What is it? It's this over this, but what does that mean? Okay? And to do that, you might use D equals RT, which is the relationship between distance, rate, and time. Okay? So if it has anything to do with speed or time or distance, you should be thinking of D equals RT and how that can help you. But if it has something to do with something else, like the example we're going to do is money, then you just have to think of what the rate is. It's something per something. Right? That's what a rate is. And if you can think of it as something per something, and then you think about so now I know what that is, then you can start to build more relationships from the question in order to develop an equation to solve. And then you think, is there some overall total? 2 things add up to a total? Or can you make 2 things equal in some way? This and this would be equal. So you're going to have a couple of expressions. Do they add up to a total, or do they equal each other in some way? And we'll kind of see, I'll show you a little bit of an example of both. That you can set these things up in slightly different ways. Now, we're not actually solving the equations once we set them up. Okay? Notice that it gives us the answer. So after I've set up my my equation, I can just use the given answer to check and make sure that it's correct. Okay? And again, that's how this the activity is going to work. You don't have to solve them. We don't need to waste time solving these equations. That's what we did 2 lessons ago when we solved rational equations. That learning goal we just took up. So hopefully we already know how to solve them. So we're not going to waste time today solving them. I give you the answer and you can just do a left side, right side check. And if you plug the answer in and its left side doesn't equal right side, then your equation's not correct. And it's the setting up of the equation that we're focusing on today. That's the whole point of this. Okay, so let's take a look at this. Coney spends $450 to buy a large amount of Halloween candy. That does sound like a lot. After Halloween, the price of the candy dropped by $1 per piece. That seems kind of crazy too, but anyway. If Coney would have been, this is the tricky part. If Coney would have been able to buy 100 more pieces of candy, but it would have cost them $50 more, that's at the new price. Okay. So they're buying more candy, but it's costing them more, but the candy costs less. There's a lot of changes in this that's going on here. How much candy did she buy? Okay. Makes no sense, right? You're sitting there thinking like, what in the world is this? Like, how would I solve that? What is it even asking? But what did I say? Don't look at the big picture. You got to do it step by step. So what's the first step?
Let X represent what it's asking.
Right. And what it's asking is how much candy did she buy? So let X represent the original, which is how much she actually bought, because then it says she could have bought, right? Let X represent the original number of candies. And then we always take that X and we do something with it. What can I do with it that's kind of simple and straightforward? Anybody have an idea?
Add 100.
And what would that be?
Let X plus 100 represent the
Like new number.
yeah.
Yeah, very good. That's exactly right. Then X plus 100 is the new number that she could have bought. Yep.
When we're writing them, do we have to write like the original number? Can we just write let X?
You can't just say let X represent the number of candies because there are 2 numbers of candies. So you've got to be clear. Okay? Some questions are going to lend themselves better to that because it'll be like Frank's speed, right? So, but you have to say whose speed or that kind of thing.
Would we need to write down the then X plus 100 is the number of candies?
Yes.
Or, okay.
Yep, I want both. Yep. Okay. Now here's probably the trick. Zach?
I'm just gonna ask, are we gonna write the new number of candies or just the number of candies?
Oh, I meant to write the new. Thank you. Definitely. Okay, new number of candies. Okay, now here comes the tricky part. Now I told you this already. It's a rational equation that we're setting up. What makes something a rational equation?
Being divided by it, like a fraction.
Yeah, and it's more than just any simple fraction. There's something important about the fraction that makes it rational. Because if I did this, like 1/2 x equals 5, that's not a rational equation. Or even x over 2 equals 5. I wouldn't really call that a rational. I mean, it's got a fraction in it, but it's not the kind of rational equation that we were solving. So what was unique about the ones that we have just been solving?
It had a variable on the bottom.
Yeah, the x is on the bottom. The x is in the denominator. That's what makes it a rational function that we were sketching before, and that's what makes it a rational equation or inequality or whatever. So x on the bottom. So I've got to get x on the bottom. So if x is the original number of candies and they cost 450, then what would it mean to do this? Right, this is step 2. And 3 to some extent, I guess. This is something per something. That dividing line, the fraction line, means per. It means divide, it means fraction, it means lots of things, but it means per. The top represents something. It's dollars, right? And the bottom is candies, right? So this is dollars per candy. But see how I intentionally did that by thinking about the units. I said to myself, I looked at this and I said, I don't know what 450 over X means. I know that 450 is the number of dollars, and I know that X is the number of candies. So I built a little fraction off to the side, dollars over candies, because 450 is dollars and X is candies. And now I can say it, dollars per candy. And now I understand that this is the original cost per candy. Okay, but I need more than one of these, so what's the other one going to be?
Yeah, 500 over X plus 100.
Very good. So what's that? The new cost per candy. What's the relationship between those two things? Just like in normal language. From the question, what does it say? Uh-huh.
Well, she's buying 100 more pieces of candy, and she's paying $50 more for it.
Yep.
And
But what's the
price is
relationship?
dropping.
There you go. So the price per piece dropped by $1. So the relationship between these two things is one of them is $1 less than the other? Is that right? So how can I make them equal each other? If I do this, 450 over X, and put an equal sign, and put 500 over X plus 100, they're not equal. Because the price dropped by $1. How can I make them equal?
What if you add a variable that accounts for price, and then rearrange it to the price?
Don't want to do that.
Would it just be -1 on one of the sides?
Which side?
Would it be on like the 450?
So you want me to do that? What do you think, folks? Are they equal now?
would it be -1 over X?
It didn't drop by $1 total, so I don't have to. But that could happen. You could have a question that was like that, but not in this case. Let me just explain again. This is the original price. It dropped by $1 to become the new price. So if this was $10, this would now be $9. Does 10 minus 1 equal 9? It does. So this is right. Yep, that's correct. Subtracting 1 from the bigger price will make it equal to the smaller price. There's something about this that our brain very often wants us to put that number on the wrong side. Okay? So you've got to really think it through and make sure you get it on the right side. The fact that you're given the answer in the activity that we're going to do means you could just guess and check. But I want you to come up with a strategy to make sense of it yourself so that you can actually figure it out on your own. And using that little trick that I just used, like numbers, is a lot easier to think through than just abstractly like this. So again, what did I do? I said, okay, the original price was $10. It dropped by $1 to be $9. What's the relationship between 10 minus 9? 10 and 9. 10 minus 1 is 9. 9 plus 1 is 10. 10 minus 9 is 1. Like there's 3 different ways you could write this. There's maybe even other ones. So I could have also done 450 over X equals 500 over x plus 100 plus 1. I mean, that's just moving the 1 over, right? But some people might think of it that way. And a lot of people also think of it this way. I see a lot of people solving these like this. Take the bigger price, subtract the smaller price, and that will give you the difference between the two prices. So, right? There's different ways that you can represent these. This is kind of like adding to a total, although you're actually subtracting. It's not always going to look like this. Something plus or minus 1 equals something. Some of the ones that you're about to start in this activity are different from that. So don't get stuck thinking all these are exactly the same. They have different relationships. But this is what you're doing. Can I make them equal in some way? That's what we did here. By subtracting 1, I made the two of them equal. Or is there a way to add them up to some total? And remember how much easier this all became once we discovered that that was the cost per candy. And if you're solving these without thinking about what this expression means, it's going to be really hard. Like you're maybe just going to be guessing and checking and not really understanding what you're doing. So this is what I'm telling you. You have to force yourself to go through that thinking and try to figure out, what is this thing? What is this fraction that I've just written out? Something per something. And you're either thinking about units or you're using distance equals rate times time. And again, you only have to set it up so we would be done at this point. Any questions?